Welcome to the Unit 11 Section 3 video on solving quadratics by taking square roots. By now, you are very familiar with the standard form of the quadratic equation. Each term of the quadratic equation is described by its characteristic when graphed. So here's standard form. We have the first term being your quadratic term, your second term or middle term being the linear term, and your last term is your constant term. The leading term is what makes a quadratic equation quadratic. Without the x squared term, the equation would not be quadratic. Instead, it would be linear. When solving linear equations, we isolate the variable by working the order of operations backwards and applying inverse operations. So we start with subtraction and addition, then we go to division and multiplication, followed by the exponential, and then anything that's in parentheses. So you notice that this is just our order of operations backwards, PEMDAS backwards, I like to refer to as SADMEP. The inverse operation of squaring a number is taking the square root. This is how we're going to deal with our exponentials. Therefore, you can use square roots to solve quadratic equations when the variable is squared and has no linear terms such as x. Okay, so this is in a case where we have an x squared term and a constant term, but no linear term. Note that every positive number has two square roots, a positive square root and a negative square root. For example, the square root of 4 is equal to plus or minus 2. This is because 2 squared gives you 4, and negative 2 squared also gives you 4, because negative 2 times negative 2 gives you a positive 4 as a result, because a negative times a negative is a positive. So let's solve each equation by taking square roots. So let's start with this first one. X squared equals 81. We can take the square root of each side, and when we do that, you have to remember there is a positive root and a negative root involved. And we can take the square root of 81 to get 9. So we have two solutions here. We have positive 9 and negative 9, which we can write compactly as plus or minus 9. For this next one, we have x squared equals 67. Now 67 is not a perfect square, but we can still take the square root of it because it's still some number. It's just some irrational number. So you take the square root of each side, and you're going to have plus or minus the square root of 67 as your roots. So again, two roots, a positive square root of 67 and a negative square root of 67. For this one, we have the square root of 32, and we have the positive and negative version of it, but we're not done there because the square root of 32 can be simplified. And when you can simplify a square root, you want to do that. So the largest perfect square that goes in the 32 is 16. So we'll take the 16 out as 4, because the square root of 16 is 4. And so your roots are plus or minus 4 square root of 2. For this next one, you notice that we do not have an x squared sitting by itself. We've got a 5 in front of it, but we can still use the same method. We first will divide both sides by 5. That gives us x squared equals 16. And then we can take the square root of each side, and that will give us plus or minus 4. For this one, we have a little bit more work to do. We can subtract 5 from each side. Then we can divide each side by 3. That gives us x squared equals 12. And then we take the square root of each side, simplifying the radical as we go. Take out the square root of 4 and make it 2 out in front. So we're left with x equals plus or minus 2 square root of 3. Recall the vertex form of the quadratic equation. A times the quantity of x minus h squared plus k. If we set that equal to 0, we have in vertex form a quadratic equation. Since the only x term is contained within a square, the quadratic can be solved by taking square roots. Note that you will need to isolate the square before taking the square root. So let's solve each equation by taking square roots. So this one, we already have our quantity squared by itself, so we can go ahead and take the square root of each side, and that's going to give us plus or minus the square root of 25 on the right side, which we can write as plus or minus 5. Taking the square root of the square on the left side leaves us with x plus 4, and then we subtract 4 from each side. But don't leave your answer this way, because we can do those two numbers fairly easily. You're going to do minus 4 plus 5 and minus 4 minus 5. And that's going to give us two solutions of negative 9 and 1, which you can write as a set. So this is our solution set, negative 9, 1. For this one, we need to get the squared portion by itself first. So we're going to add 5 to each side. Then we're going to divide each side by 2. That gives us 13 halves on the right side. Now we can take the square root of each side. That's going to give us plus or minus the square root of 13 over 2. But we are going to want to rationalize our fraction on the right side. So we're going to have x plus 2 equals plus or minus square root of 26 over 2 when we multiply the top and the bottom by the square root of 2. And then we're going to subtract 2 from each side. And that leaves us with negative 2 plus or minus the square root of 26 over 2 as our solution. For this problem, we are going to divide each side by 3. And then we're going to take the square root of each side, remembering to do plus or minus the square root on the right side. That leaves us with x minus 2 equals plus or minus the square root of 120 over 3. When we rationalize our denominator, we multiply the top and the bottom by the square root of 3. And then we're going to add 2 to each side, and we'll go ahead and simplify the square root of the numerator to 4 square root of 30, because we can simplify it down to 16 times 30. For D, we have 16 times the quantity x minus 2 squared equals 49. Divide each side by 16. Do plus or minus the square root. This one comes out nice because 49 and 16 are both perfect squares. So we can make the right side plus or minus 7 over 4. And then we can add 2 to each side. But don't leave it like this, because 2 and 7/4 are just numbers. You can easily add and subtract them by making 2 the number 8 over 4 and getting 1/4 and 15/4 as your answers. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.